All right. Again, grade 12s, I would like to continue with these examination type questions for this topic. Um, they are making it more and more interesting as the years pass by, and this is one of the most interesting ones that we've had so far. So I would like you to look at it, and from the questions that I sent to you, you can easily remember that. Let me just make sure I phrase it exactly as it was phrased in that question. So it mentioned that in the diagram, a circle having center M touches the x-axis. It touches the x-axis. If something touches the x-axis, it means the x-axis happens to be a tangent to the big circle that we've got on the board. And we were also told that it touches both the x-axis and the y-axis at these given points right here. So for this big circle, the x-axis and the y-axis are tangents to it. So we want to keep that in mind as we are carrying on. All right, so here is another piece of information given. We were told that the coordinate of M there and how N is the center of this green circle that we have, the smaller circle. So N is the center of that one. And then this line here is the tangent to the small circle. So that is the information that was given to us. So for starters, we were then asked to determine the equation of the circle centered at M in the standard form. So we would like to determine the equation of this circle right here. That was the first thing asked here. So let's try to do it. Normally, if we want the equation in this form, from what we gathered back then, we know that this will be representing the coordinates of the center of the circle. And then this one here, we just have to know the radius of the circle. So what we have to do now is actually to notice the tangents, because it does look like we do have 2 points. If we wanted to, we could form 2 equations, but here we have 3 unknowns, A, B, and R. So we needed 3 coordinates minimum, so we can form 3 equations. So in this situation, it is actually our analytical methods that we're going to help us. Just that part of remembering that if this is a tangent, we know that this is a vertical line. So if I ever draw the radius from there to the center, let me just put it in red like this. If I draw the radius of the circle, what we know is that the tangent and the radius must be at 90 degrees to each other. That part we already know. Now here is what I'm saying. If we have a line that is perpendicular to a vertical line, perfectly vertical line, that line should be certainly a horizontal line. Now what we know about horizontal lines is that the y value all along this horizontal line, even if we were to extend it, the y value here will not change. So that lets us know actually that the y coordinate for M will remain 1 as well, because then it has to be on this radius, and the radius happens to be perpendicular to a vertical line, which means it's horizontal. If I use the very same strategy, I can come and say, here we have the x-axis, which is horizontal. If I draw the radius from there to here, what we already know about the tangent and the radius is that they meet at 90 degrees to each other. So if this one here is a horizontal line, this one has got to be vertical because they are perpendicular to each other. So if it's a vertical line, what we know is that on a vertical line, the x value does not change. It is the y value that changes. Here it will still be -1, it's something else, and here it will still be -1. So that is how we managed to crack the coordinates of M right there, the center of the big circle. So now we know the coordinates of M. So I think what you are ready to do is to write them down here and say x, since the x value here is negative, it's going to be x plus 1 squared, and then you say y minus 1 squared. Now you have to get the radius of the circle. Well, in this situation, since these are, we mentioned this is a horizontal line, so if we want to find the distance on a horizontal line, we just use the x values. We can just subtract these two x values, 0 minus minus 1. So it will simply be 1 unit. We don't use the distance formula, for a horizontal line. Neither do we use a distance formula for the vertical. If it's a vertical line, we just use the y values to get the distance, 1 minus 0. So either ways, you get the radius of 1 anyway. So it will be 1 squared and it remains 1. So this was the first question that was asked there, and it needed for you to understand a few things before you can answer it, and not to make some weird assumptions as you go. So everything you need to have a good reason for it. Now, the second question that was asked was for you to calculate the coordinates of C. Now, from the diagram, looking at C, one may be tempted to just carry on with this radius and carry on all the way to C. But the problem with that is that C might be somewhere not on this particular line if I carry on. So it's not good to assume that C is directly above M when we were not told that. We were not told in the statement that there is a line here, a vertical line that joins, that actually joins this tree. So we cannot really do that. However, in this particular situation, you will notice that that trick was going to work anyway if you were to use that. So what we can do is to actually use this diameter here. If you remember, the midpoint formula says this: x1 plus x2 over 2 and y1 plus y2 over 2. That would be your midpoint formula. So what I am saying is, we don't know what this coordinate is. We're calling it xy. If we wanted to find n, if I wanted to find n, which we already know is the midpoint, we were going to say x plus 0 divided by 2, isn't it? And then we're also going to say y plus 1 divided by 2. Remember, that is what we're going to do to get this midpoint. But we already know that n happens to be minus 1 over 2 and 3 over 2. So normally I just do this step fast. I'll just say what we can do now is to equate these two. This is what I've been doing all along, and I'm hoping you were following. So today I decided to show you the steps. So you can equate this one to that and equate y plus 1 over 2. You can see how that should be equal to 3 over 2 like this. So normally I just show the step. As you can see, if I multiply by 2 both sides, I should actually have just x here, and x is going to be negative 1. And if I do the same for y, if we multiply 2 both sides, the 2 will cancel, and if I let 1 go to the other side, y will be equal to 2. As you can see, the coordinates of C will become minus 1 and 2 there. Just the same way, a guy who would have guessed this one, right? Like if you were to say, oh, it's a vertical line, you are still going to get to minus 1. And from here, remember we say the radius is 1 unit. So on this one, you're just going to add 1 to get to 2. But that will be a big assumption you're making right there. There isn't enough reasons for you to use the circle. But you have all the reasons when you're using the smaller circle. Either ways, you're going to get minus 1 and 2 anyway. Alright, so let's quickly find out what else was asked. You were to show that the equation of the tangent is y minus x plus 3. So they want you to show, if you want to show something, it's rather y minus x is equal to 3. So you want to show that this tangent right here, that would be its equation. So don't be tempted to use something that you want to show. You practically go and calculate or determine the equation of this tangent DC. I think you remember very well from the lessons of tangents that if you want to determine the equation of the tangent, you have to first of all find the equation of the the gradient of the radius. So what we said was that the radius and the tangent are always at 90 degrees to each other. So what I am going to do now is to just determine the gradient of the radius there. This is minus 1. You know, these are fractions, so I'm going to just use this one because it's a straight line. So please, people, let's remind others quickly. x2 minus x1, like that. So if I want to find the gradient of this line, I can say 2 minus 1 divided by minus 1 minus 0. As you can see, the gradient of the radius will be 1 over minus 1, which would definitely just be minus 1. So therefore, from that, we can notice that the gradient of the tangent will be the negative reciprocal of that. It will be positive 1. From what we know, if we want to determine the equation of a straight line, this is where we go. Our gradient is already 1, so it is some x plus c. We just have to substitute one coordinate here, and then we should be sorted. One coordinate which is on this tangent, and we already have minus 1 and 2, so it's not an issue at all. Like this. That's how we see how our c is 3. So from what we know, this line should be written as y is equal to x plus 3, but if we want to put it in this form, we would just take x to the other side, and then we should have this equation. So we managed to prove it like that. Okay, so that is what I was expecting from you right there on your question 3. Let's quickly finish this question off. There is, however, still question 4, 5, and 6. So on question 4, that one wasn't exactly a straightforward question. So it said, determine the values of t for which the line y is, now they did this, y is equal to x plus t. Look at the relationship between these two lines, please. So determine, I'll read that again, determine the values of t for which this line will not touch or cut the smaller circle. So please, here, if I say t is equal to 3, the line will be touching. This is the line that we'll be talking about. As you can see, it's just touching the small circle. So they don't want it to touch. So obviously t cannot be 3. And in fact, we can see the gradient is going to be maintained as 1. So you just want to draw some lines that are parallel to this line that are not touching this circle. Please, people, if I do this, if I do something of this sort, notice how this line is cutting twice. In fact, even if I do that, it's cutting actually twice, which means, as you can see, if that one was 3, it means I am going, the c value there will be lower than the c value for that one, and even the c value for this line here will be a bit lower. And there is one line, even if you carry on like this, it will be cutting as you go, cutting, until a certain time when it just touches, which is just right here. You draw a line perpendicular just right there. It's also a line that has a gradient of 1, and it's just touching the circle there for the last time. So if I draw another line over here, now you are very sure that this line is not cutting the green circle. So you can see that if y value is smaller than 1, the line will not cut the circle. If it is 1, it would touch only. If it is greater than 1, it will actually cut twice, greater than 1. But when you go to 2, it will still cut twice. 2.5, it will still cut twice. At t is equal to 3, it will cut once. But if I go to t is equal to 4, what it means is that that line will be over there. The y-intercept will be way up. It will be maybe y is equal to 4. As you can see, that line will not cut this circle. So if you were listening to all that, you notice that the only time we don't cut this circle is when t is smaller than this value, or t is greater than that value of 3. Remember, we only have 2 tangents here. The tangents to the circle please keep remembering that for this line here, there are two lines that are always perpendicular to it if it is a circle, the one above and the one below. All right, so these are those type of questions that require a lot of thinking to get it. So if you were listening, I said t should be smaller only when t is smaller than 1, and also when t is, we said greater than 3. If it is smaller than 1, these are the lines that are not cutting down here. In between, all the time in between, it's cutting twice. After that one, you can see just 1 is left. So this should be your 2 solutions for number 4. All right, now I hope you can still see the diagram. I'm going to need it without those tangents that I drew everywhere. And I'm hoping that you understood what I just mentioned there. Remember, it's the y-intercept that we'll be talking about. That is in place of t. All right, so with that in mind, let us quickly see if we can answer a few more questions on the same topic. Okay, so we have to answer question 5 now. And question 5 mentions something else. You have to listen to this closely. So the smaller circle centered at N is transformed such that point C is translated along to the tangent, point C is translated along the tangent to point D. Now you have to calculate the coordinates of E, which is the center, the new center of the smaller circle. Now here is what we are saying. This point right here was translated from there to here. So the first thing we have to know is the coordinate of D. That will really help us. Now the coordinate of D will only come if we remember the equation of that circle, and the equation of CD. We remember that the equation of CD was y minus x is equal to 3. We were asked to prove that that is the case in 4.3 right there, question 3 rather. So as you can see, we can see that at point D, y is equal to 0, like that. So we can easily get the x value to be negative 3. So in this situation, D itself happens to be negative 3 and 0. Those are the coordinates of D. So people, we moved a coordinate which was at -1 and 2, and it was moved to a coordinate which is now -3 and 0. So we have to think, we were told it was transformed from here to there. So if I look at it, let me just say this is the image of C after this transformation has taken place. Now I think everyone can tell that if you move from -1 to -3, it's like you have moved 2 units. It's a translation, 2 units to the left, isn't it? You can see that's what happened. And if you move from 2 to 0, it means you moved 2 units down. So this is the translation that took place here, as we moved the point C all the way to D, right? Now, I want you to use the same strategy. Remember, they didn't just move point C, they moved the whole circle. So it means every coordinate on the circle actually has gone through this type of translation. So if I am asked to take now n, which is -1/2 and 3/2, and I want to actually translate it or transform it using this rule here, I can easily get the coordinate which they said we should name it E. So that coordinate, we can just say if we want 2 units to the left, we subtract -2 here. We just say -1/2 -2. I think that should be easy enough. It should be -5/2, and then again you say 3/2 -2, you should now have 1/2. So that would be the coordinates of the new center of the circle if we translate it using this units right there. Okay, so let's quickly find out what else was asked. Now, it says if it is given that the area of the quadrilateral OBCD, so look at OBCD. I think you're seeing it. So B is over here. So it's O, B, C, D. So it's this whole quadrilateral right here, O, B, C, D. This whole shape in here. So they say that if the area of that is equal to 2a squared, they're saying that the area of that is 2a squared. We are required to show that A is equal to root 7 over 2 units. Root 7 over 2 units. There was a condition given in the question that A happens to be greater than 0, so we are going to just use that one as well. So we were told the area of OBCD in terms of A, and now they want us to find A actually. So what we are going to do is to see if we can really calculate the area of this quadrilateral over there. And I think we won't find that difficult since we were once in grade 9 already and in grade 8 as well. So those are the kind of things we will not struggle with. If you see a shape that you don't have an immediate formula for, you know that you can easily divide it into shapes that you can find things. So in this situation, you could actually use even the two triangles. You can divide here and say there's a triangle there and the triangle there. Both of them will be 90 degrees. They have a right angle triangle. It's just that using that method will require that you calculate the distance from here to there, and then rather here to there and here to there, and also the distance from here to here. These ones were going to be easy. So the faster method that I noticed, since now we knew that there is a line that can actually go through there, I felt dividing it like this will make life very simple. What I'm saying is, if this is our quadrilateral, we can easily divide it now into this triangle and now this shape over here, which everyone knows to be a trapezium. That would be easier and faster rather than cutting it like this. Even if you do, you will still get to the same answer anyway. So the total area of this is actually going to be the area of the trapezium, which we already know the formula to be this: half sum of parallel sides multiplied by the perpendicular height, and then the area of a triangle, we know that it's half base times the perpendicular height as well. So this will be the area of this quadrilateral OBCD. So please people, these are the two parallel, because this is vertical and we already know how this is vertical as well. We can see there are 90s that are still there on the diagram. We just have to establish how long this is from here to there. And since it's a vertical, we use the y values. So from here to there, it's 1 unit. And from here all the way to west, the y value for C is 2. So this one is 2 units. So let me write that before we forget. So it's 1 plus 2. I added the length of the two parallel sides. And this, people, is the perpendicular height of the trapezium. So the length from here to there, how many units? And I think you're noticing, since this is at -1, 0, it will simply be 1. Okay. Now, there is a 90 degree here. So we can easily say half base times height. We need these two sides. So from -1 to -3, those ones are actually just 2 units. And from -1 to 2, or rather from 0 actually, if I am looking at the y values, from here to there, that's 2 units as well. Let's just confirm that. From here to there, that's 2 units, yes. And from here to there, that's 2 units, yes, yes. So that would be the area of this. So this is going to be 3 over 2, as we can see. and that one is just 2. So we should easily find that to be 4, is that 4 over 2, 3 over 2, that should be 7 over 2 square units. So this will be the area of this. From what we were told though in the question, the area of this quadrilateral happens to be equal to 2a squared. So all I am required to do now is to say, well, 2a squared must be equal to 7 over 2. And if I divide by 2 both sides, I'll get a squared as 7 over 4, which if I get the square roots both sides, you can tell how we will get plus or minus 7 over 2, isn't it? But we were told that a was greater than 0. That is why we will take root 7 over 2. So we managed to show that a is equal to root 7 over 2 units. That is what we were hoping to do. All right, so that is enough for this question. Let's see if we can add a few more from here and get as smart as possible, all right? Good.